Okay, so we will continue. Welcome back after tea break, and we will continue with our lecture. We are still missing 30 samples. So, what is principle of measurement in field? First measurement for sure will be very high amount of measurement data. You need to be very careful about this one, and of course you need carefully plan also timing of measurement. Why? Because you definitely want minimally one rotation of wind turbine, the wall, not only part, because it will be hard to evaluate how to say progression, how it looks like if you have only part of the true rotation. So you need start with nominal wind turbine rotation speed. Of course, from 0, but it is static object, 1 RPM, 2 RPM, and so on, up to 10, 12, 14 RPM. But 14 RPM will be for some small size wind turbines, because they have higher speed, but for modern one, some bigger one, it will be about 6 up to 8, something like this. So from this rotation parameter you can evaluate time of your measurement. From time of your measurement you could evaluate what is your and from bandwidth you can evaluate some sampling rate, and now you need to fulfill, okay, this sampling rate is adequate and is enough for me or not, and then I need to change the whole hardware to get a higher sampling rate that is supported. So be careful about this. Our measurement, how I already say, is continual measurement with static antennas, so we ignoring the movement of the radar antenna. But it is never mind, we just get response if, but in even our radars that has rotating antenna, usually they have mode without rotation also, of course, because this you could set how you need. So this approximates situation of fixed beam sector radar, and it turns our dataset into clean function of blade motion only blade motion, because you want the lowest influence of another reflections, because you want just make analysis of wind turbine reflection. And generally all these things about designing of measurement chain and so on, it is valid for any other measurement. It is not only for wind turbine measurement. Always, if you need to make some analysis of some phenomena, just focus to phenomena and try to limit the most other things or artifacts that can influence your measurement. Then it will be much easier for analysis, because it will be just clear phenomena. So for each scenario, it is mean for each place where is wind turbine located, we choose several polarization combination, vertical, vertical, horizontal, horizontal, vertical, horizontal, and so on. Very pulse parameters, so we changing tau to different values. I will present usually always one where was the best measurement of us, where is the phenomena best visible, but made a lot of them with different parameters. Vary pulse parameters, so if it's unmodulated, modulated, and so on. Record multiple bursts at different times to capture variability of wind speed and direction. This could be time demanding, because of course you can spend hours in one measurement place, because if wind not changed, then you will still have same or similar results. And try always different position around wind turbine if it is be possible. Because why? Because you choose you change your your angle, and then you can easily see if and you know already from yesterday analysis that when I changing your angle, I am changing amplitude of reflection. It is this breathing. So when you are already out, try measure what you can easily say. And always before start of measurement, be sure that your antenna pointing to wind turbine exactly to maximum of antenna beam, because it is also not so easy if you understand me. You are 1 kilometer, 1.5 kilometer far away, so just be sure that you are looking to exact position. And what I already mentioned, for all settings you need to record metadata. It is crucial, because from IQ data, from raw data, you can't recognize anything. It is IQ samples, nothing you can recognize. You don't know these settings, where it was, what was setting, what was amplification of power amplifier, you don't know. So exact timing, weather conditions, turbine operation state, manual notes, and many other photographs, videos. From video is powerful. You could see a lot of parameters, especially rotation speed, even angle from photo video you could derive in somehow. If you could have it like GPS position of wind turbine is clear, you can find it on map, but record GPS position of your measurement place. It is important. From 2 GPS position you can make derivation of angle, because everything is clear. Oh, we forgot GPS position, and it is really hard to evaluate, because of course you know where you was, so you open map, but it is plus minus 10 meter, 20 meter, there could be some error. Of course with your GPS measurement there is also error. There is multiple solution. You could use some precise GPS, or you can compare with more GPS devices, because everybody has GPS in mobile, so even if 3 people will be there, you can compare and make some averaging of error, because I don't know, GPS is like when you are using probably navigation, when you go somewhere or something like this, GPS is not much precise. It will be plus minus 10-20 meters, like rough estimation, so it is not quite. I know that on a map show you that you are in right position, but it is just visualization. Don't believe on these values. So without metadata, post-processing after some months becomes very difficult, but I better use it will be impossible. There is setup. You can see that there was some bigger track, because you need to place all this antenna, everything to your track, and there is again, it was ugly weather and almost start raining, so we are placing everything inside track. This is GNU radio example, control PC, SDR, laboratory power supply, there is power amplifier and so on, and there is generator. So there I will put few information about site selection where we make measurement. During tutorial we will play with live demo, we try looking at panorama, you will try looking for some good measurement positions on street view, and so on and so on. So first wind turbine was Vestas V90, coordinates in north and east is this one, so you can easily later add to map and check it where we was it measurement. Altitude was 500 53 meters, nominal power is 2 megawatts, rotor diameter is 90 meters, height of hub is 80 meters, total weight is 125 meters. So it is mean when this blade will be just in same position like tower, it will be 125 meter. This is just example, how to say, example picture. It is not from place measurement. I will have later this. And there you can see a map. This was main road, very high traffic, so we can't go to this place or this place, if you understand me, because it will be reflection from this wheel, this micro Doppler and all this thing. So there was some agriculture, small road, just go to field, and we measure from this position. It was GPS is this, GPS of wind turbine is this, and this was about 434 meters far away from wind turbines. We call it scenario Kamen because the closest village is named Kamen. By the way, one thing, if I will translate to English, Kamen mean stone. Strange name for village, but it is stone. This Vestas V90 is very common in turbine model in Europe. It's in category smaller one. It is not so big, like average, but it is common. You can see this wind turbines very often close to roads, villages. Be careful and try always select position where you can minimize clutter. And so avoid buildings, barns. Barns is very dangerous. They are very often metal. And imagine that you will have barn there or close. You will get strong reflection from barns because they are very often. Maybe you are looking about weather. It was nice sky, good weather, and it is autumn. Nothing green. It is just before winter, I think end of October or something like this. There was no possibility to see wind turbines without tree lines, but we make, okay, I will explain. This and this, we need pointed just for blades. We don't want this tree, so it is not for instability. It is just correction.
For the stability.
Stability also, of course, but this was for correction, like angle. I forgot to tell you. And I will show you video. Okay, I will show you video even with sound, and then you will understand that measurement was not so comfortable. Power generator, of course. Okay, and now I will again switch off sound and we will run again. So this video, it is just made from a mobile. You don't need anything fancy, of course. But check the blades. From this, I can easily evaluate speed of rotation. Of course, I can zoom it, something, but you can even load to some video editing software for individual frame and really get precise value. Of course, you can just guess or just make some estimation, but video is really nice. It is very good. It is a lot of information. Even told you about weather conditions. It is also not bad if you forget. I know that it is multiple time repetition of this, but it is important. It is great source. You will agree. You will work with videos, so you will confirm me. There, what is important is digital elevation model. I already told you, we already discussed yesterday how important is the digital elevation model and what is it. So there is in 3D, it is in MATLAB. There is like in 2D, so you can see that there is almost flat. There is not so big, any valleys, some hills, something between measurement place and wind turbines. By the way, this picture, it is just please, it not completely correspond to ratio. It is just picture, but this elevation profile corrects. There is perfect. This is from street view. It is from SAR, synthetic aperture radar. So you can see that there is field. Of course, there is green. In our is brown because this was captured on maps. It was from different time of the year. So, but you could make easily evaluation. Pardubice is located somewhere here, so it was about 50 kilometers, 60 kilometers far away from us. So, from this information, just based on elevation profile and maps source, and it is not important which map source you will use, we could easily compute slant range from radar to turbine, elevation angle to the hub, and path of the beam above ground. So you can see also what is elevation profile. And all this is crucial for measurement planning. You can just do it before measurement and it is perfect. Of course, you can, how to say, you can arrive to perfect planet measurement place and you can discover there will be some, I don't know, some another new object that is not in a map. It could happen, but you can't do it anything with this. Then there is parameter of the measurement. So sampling frequency was 40 megahertz, PRI was 500 microseconds, it is micro, not U. Pulse length was about 200 nanoseconds, so range resolution around 30 meters. Carrier frequency 3 gigahertz, so you can see exactly S-band. Polarization both vertical, horizontal, and this was testing measurement. It was first time measurement outside of real wind turbine, and it was about 5 seconds, but we made a lot of them, a lot of this measurement. Why only this short? It was just for validation, and second thing, we discovered that we have some problem with this cache overfloating, so next time we plan more carefully. But it is happen, and for this reason we select relatively close site, because always something happen, be sure. And exactly these settings you will use for your simulation, and then produced results must be similar. If not, model has a problem somewhere, of course, or it is not adequately, how to say, it is not with high confidence or something like this. And this is measurement, it is real data, it is not any simulation, it is real measurement of our wind turbines. Of course, there is adaptability of colors. If you will look on raw data, there will be some noise, but we just adjusting like level of colors to be more and more visible, but we don't change data. It is just about visibility. So what do you think that is this phenomena? How we call it? We have Flash. Exactly, flash. It is this where you can't do it anything with this, because it is, of course, there is Doppler frequency and this is time. And always when our signal was completely in phase, each blade element get 100% reflection and hit back to target, and it is this one. So if I will mitigate this in this specific time, I will mitigate everything, even target. Just in this time, it is relatively very narrow. Just ignore this resolution cell, but it is only probably one cell during one time. But check this. Free sine wave. Of course, it is not looks like nicely like from simulation, because there is lot of another reflection. You need have good visualization, I agree, but it is there. It is for one measurement, there is another measurement, and so on and so on. We made about 20 or 30 of them and make comparison of all of them, but it will be very boring if I will show you all of them, because it is just for confirming that works. This is for vertical polarization. Check not only this flash, but even this reflection from blades element that are rotating with lower speed and they are closer to rotor, there is reflection. If you check in horizontal polarization, it not looks like so nicely. This reflection is not so nice at this lower speed. Still you can recognize this sine wave, but it is more and more harder. Why? Because this blade shape is extremely complicated shape. So on horizontal polarization, there is not so many reflection about this one. Then if you compare with vertical polarization, but you don't know it, so make all possible combination of this polarization, and then you will gather the best one. And okay, we don't make we made also cross polarization, but cross polarization, it was the worst results, almost nothing visible. So I even don't put results there. I think that I have in second scenario. Then we go to Skalky Protivanov. It is another site where was another wind turbine. It is RE power MD77, altitude 676 meters, nominal power 1.5 megawatts. You can see it was much bigger wind turbine. Rotor diameter 77 meter, height of hub 85 meters, total weight 123.5. It was close to Protivanov, this village. This is measurement place. This is a location of wind turbine. There was multiple wind turbine. There was one, second, and third, but this third was really small one. It was some like original installation for validation of place or something like this. And now they want to remove this free and install new one, but it is close to weather radar and they didn't get yet permission. Just for information. This picture is just example of this wind turbine in details, but this is example from our measurement. It is against video, so you can see rotation, you can highlight, and if I am not wrong, yeah, both are rotating. And exact location was there. Okay, can see it. It is just exact location. It looks like in the middle of the nowhere. And there you have both wind turbines. So it was about 1 kilometer. And you can see, you can just make, we will play, okay. Still visible, I can show you that we could go like example there. Okay. And later we will play with this one, exactly. And you will help me to find some more position and so on. So, there is presentation of digital elevation model of the scenario. You can see that again relatively flat. There is not any obstacles. Of course, we select position where is no obstacles. We try to plan carefully. So there is viewing from MATLAB where in 3D where is position of radar and wind turbine, and it was about 1 kilometer 900 meters. We made more measurements around more places of wind turbines to get better more view, more yaw angles. This time the preparation was better, so you can see the time of measurement changes. It is from 5 to 18 seconds. Sampling frequency was same, but PRI is doubled to 400 microseconds. Pulse length is same, 200 nanoseconds. Carrier frequency again 3 gigahertz. Generally, we don't change carrier frequency because it is based on RSDR, so we just measure on still same carrier frequency. And we measure vertical, horizontal, and cross polarization. I remember in scenario 1 we measure generally only vertical, horizontal, but now it was second place measurement and we was a little smarter, so we planned more carefully. And there is result. Okay, this is 5-second measurement. I put it on detail. It is from horizontal polarization. Again, check this one. You still can saw it, but it is not so nicely visible, this sine wave. You know, it is better for, how to say, if you want to fit your measurement with simulated data, generally use flash. Because then when you make like intercover boat, you can see that there is it. There is 16-second measurement. Why there is more this? Because it is longer measurements or more flashes occur. And you can see that we are on the edge of Doppler. You can see we are this is maximum of Doppler. And if will be this up to there, then will become there. And we have problem. So it is on the edge. It was also testing if will be it was of course a higher speed of rotation or something like this. There is vertical polarization measurement. And by the way, I don't mention in all picture, but this red one, this very strong reflection tower. You can see easily tower always because it static, exactly 0 Doppler. And cross polarization. No. We figure out that cross polarization is not for us because there is almost nothing visible. Okay, you can see these artifacts. There is in this band something, but honestly, free sine wave. You need be really good in guessing. I don't see it. So cross polarization generally we figure out that is not good for us. So vertical, horizontal, okay, but cross polarization, no. Next, it was measurement in Austria. It was really large wind turbines, and it was a close village of Grob Schweinbad. Sorry for my German, I don't speak German. It was one of the biggest wind turbine that is on market. Okay, it is measurement from 2023, so maybe now is some bigger, but generally it is one of the biggest. Vestas 150, there you have location. Oh, sorry, it is Czech, I forgot to translate. It is altitude 250, power 4.2, rotor diameter 150, tower height 166, and check the total length, almost 250 meters. It is really big one. There is detailed picture. It is not ours, of course, it is somewhere else, but we don't have access exactly to close to site because it is protected area. There was a lot of wind turbines, so we can't go too close. So if I will show you later, I will show you picture from measurement, but it will be small one because we was in a longer distance. There is elevation profile, so you can see we was down, and there start be little tricky. We need to be careful to not hit, how to say it, with line of sight ground. But why we don't go there or there or there? It is too big. First time we will be very close, but second time it was protected area. We don't have permission to go there. There was some fence and something like this, because in this area it was about 10 or 20 wind turbines, and they protect it and close it. So you can see that there we have some limitation. It is about 40-50 kilometers far away from Vienna to north, something like this. And elevation profile. And there you can see picture from measurement. So parameters was exactly same like in Protivanov, like in measurement scenarios too, due to reason that for us working in the best way, and we could maximize time of measurement. So if works, don't change it. It is my colleague Beck that is main contributor of mathematical model Karel Jurica. I already mentioned of him, so you don't see him personally, but only his back, but it is him. You can see it was also late autumn, so it was almost winter, not nice, not so nice weather. And there is measurement and check. It is big wind turbines, big reflection, and speed of at end of the blades was very high. And check this and this. First time what we see aliasing, when aliasing occurs in both like in horizontal, so in vertical polarization. Why occurs? We was relatively close, because of course we must be close because we have some limitation in power, but reflection was higher, and I am just checking. V was about 1 kilometer. Yes, 1 kilometer, and the reflection was so strong that aliasing occurs during our measurement. So this will cause exactly your mitigation algorithm big problem. And last scenario that I will present you, it is again from group Schweinbart, but from different position. You can see that there was same parameters of wind turbines, but from different position. Now we was there, and it was about 1.3 kilometers. So we are in far in another position. Scenario, there is example of digital elevation model scenario, measurements, and check there was multiple wind turbine. So it is clear why we can go there, because it was protected. There is example of measurement place. It is looks that we measure multiple wind turbines. No, beam was really narrow. Of course, you get some reflection of side lobes, but it was relatively low, so it not so many influence. But we measure this one, not this one, because and check what is angle. It is in a maximal Doppler, because we are just opposite. And it was reason why we want to measure like this, because it is like confirmation. Okay, made measurement from this position. When you have this rotation, you can measure a wall, because it will be just a reflection of static, and you will see only on Doppler 0. So there is nothing. So we want to make measurement, because we was interested, if you are in like this position, the RCS, of course, the speed is high, Doppler. But the reflection area is smaller, because you are from this position, and we want just to confirm that if RCS is enough big to show it in our measurement. And how you can see it was nice. And of course, check horizontal, vertical, and very, very, very strong aliasing. And I can confirm that it's one of the biggest wind turbines, so I think that the worst scenario, you can't have it about aliasing, because the bigger ones, they are not exist yet, they are planned. I think that in next 3-5 years, about 2030, they plan that they will have maximal height about 300 meters. This is 250, 60, something like this. So you can see that this increasing of size of wind turbine is relatively linear, from 40 meters up to now 300 meters. And cross-polarization results. Not much useful, of course. Only what is visible. You can saw it, this flashes little, but very, very little. So you can see that cross-polarization is not much useful, because they not provide adequate result. And now we will have like live demo. I will show you on maps. First, we will check to 2D map. I will hope that everything works, because how is something live? Always something badly happened. It is classic. Oh, this okay. First work. No. Okay. I will open again. Sorry, I will not close it. So it is on Google Map. My system is in Czech, so you can see in Czech, but it is never mind. This is just name of village. So you can see, if I will go like this, it is It is wind turbine Kamen. This is this main road. There is wind turbine. There is wind turbine. You can see it. This is access road to wind turbine, and our measurement was there. And exactly, check this. Something agriculture things there, and you can't, you don't see it on this. So always check satellite map. And of course, it is changing in time. So it is this one. What is most useful is this panorama. Sometimes looks like toy, but check, you can easily watch it. It is look like rotation. You can easily watch it, you can easily plan, okay, there is trees, because first time we won't go from opposite side, but we unfortunately see we won't go for measurement to this side, but check, unfortunately, okay, there is visible, you can see, but very small, there was reflection, not good place, so we don't measure on this place. I think that will be same what I already show you now. Yes, it is this. It is just different view if you don't want to spend the time with founding. So yeah, it is this one. So it is this different view. I recommend you use also this mappy.com. It is look that I am advertisement for our site of maps, but it is not exactly true. Please, there you can somewhere switch it to English, it is no issue, only don't know now where. And what is advantages of this? Okay, I need to check where switch to English. Okay, it was easy. And there is tools. Distance and area measurement. And check. I will select point. And I know, okay, 400 meters. And if I will make click, in same time I see elevation profile. Very useful. Google Maps don't have this feature, so or if they have, I don't know how to use it, because I never found it, so maybe correct me, I don't know. Do you know if is there distance feature in Google Maps? Maybe you have more experience, I really don't know. But this is perfect, because always I can just, okay, quit, I will use measurement again, and from okay, new measurement, and check if I will, oh sorry, new measurement from this, and now I can just check, okay, there is good position, 800 meters, 600 meters, I can, I don't know, 4 kilometers, and so you can easily evaluate place where you want. And always when I make click, show me distance and profile. Just for fun, we can check some place in your country. By the way, in your outside Czech and Slovak Republic, there not will be panorama. I think for sure not will be. So for this reason I always show both Google Maps worldwide, but for measurement distance you can use it. Our maps, it is okay and it is good. But for street view, unfortunately, you need to use only Google Maps. But I don't, it was about Natham, I think. Okay, but I don't see wind turbines there. But it's possible that our maps use another source and there is not visible. It is another things. Use please more source. Like this source, Maps Google, Open Street View map, all these three together. Why not? Because it is quickly evaluation, and in all three, maybe you have additional information, some more information, because they use different source of this geo object. So is it clear that somewhere could be, somewhere it's not? And this panorama distance, it is, I think, that the same. Yes, it is the same. So, it is about manual measurement. I already see you distance, and there we have another example. It was close to Svetavi, and it was there is our wind turbines, two of them, and due to fact that this is very hilly, it was really hard to find place of position, and in 2D maps it is this one. Okay, some track which we don't want it, and somewhere there sometimes it is really annoying word. Yes, can you see it? 1, 2, 3. But sometimes it's hard to find good position, really hard. You need to make coffee or tea or something and spend hours and just finding where is best possible visibility and so on. So it is not easy, especially if you have high density of roads or around buildings or something like this. Sometimes it's really hard to find good position, but it is still better than go there and just driving by car around and finding. So it is still better. The street view, but I think that will be, yeah, it is this position, so exactly where I was. You can make measurement from this side, and in panorama in our, no, I am out, it was somewhere there. Okay, I am in bad position. No, this is some local. You can see it is not easy to find. I will not spend more time on it. But if you can check this distance, what we already prepared, it is about 7 kilometers. It is just example how sometimes could be really hard found good position. And I'm sorry this lecture was a little shorter. It was last slide, so if you have any question, we still have about 15 minutes, something like this, so we can discuss. We could check also OpenStreetMap. This I didn't show you. It is this Janov, but we don't care now about Janov. Okay, there is Protivanov, and check it is this free that I already show you. I will just switch to English. And check. I I won't get information about these 3 wind turbines. Okay, and there is information, but just where is position, not any more information. So exactly what I told you, sometimes information could be there, sometimes not. And now is a good example where is no information. So if you don't have any question, it is little shorter, but it is hard to evaluate which lecture will be. It is first time what I have short lecture. Usually I have longer, so I hope that is never mind. Okay, so thank you for your time, and after lunch we will continue with tutorial, if you agree. Okay, thank you.